IOStack, software-defined storage for big data. IOStack is a European project that involves the Rovira Brasília University, Arctur, Barcelona Supercomputing Centre, Eurocom, GridPocket, IBM, IDIADA and MP Store. Today, we live in a world of big data analytics. Companies of all kinds generate enormous amounts of data during their daily operation. With analytics applications, this data can be transformed into meaningful information that can help companies to improve their business processes. As a result, companies that use analytics platforms become more efficient, more innovative, and more competitive than before. We're going to show you how a simple analytics platform works. Large datasets from many sources are normally stored in a storage cluster, and a compute cluster runs one or many data analytics applications. These analytics applications fetch data from the storage cluster to execute computations that produce information that is meaningful to data scientists and operators. However, this apparently simple life cycle raises important challenges. It is complex to manage and has limited flexibility. Let us illustrate this with real-world use cases. Problem 1. Need for advanced data services. For our first use case, GridPocket is a smart grid energy company that manages large amounts of data from home users' electricity meters. In their daily activity, GridPocket data scientists execute queries on that data so that they can understand and model the energy consumption of users and even whole cities. Let's look at a simple query. We want to know the number of users who appear in our data for last week. As can be assumed, computing this query needs only a small fraction of the total data stored in the storage cluster. However, most analytics applications need to fetch the entire dataset from the storage cluster to execute this simple query. For GridPocket, this is an important source of inefficiency, as query times grow linearly with the dataset size. Problem 2. Need for flexible storage management and optimizations. Another use case in our project is IDIADA, an international company in the automotive sector. IDIADA generates and manages large heterogeneous datasets. In this example, we can see two sets of computer instances. The first stores data from car crash simulations, and the second manages information from car standardization processes. Both types of data are very different and may also be subject to very different requirements. That is, if the simulation-like data is known to be compressible, an administrator may want to enforce data reduction techniques on storage flows of compute instances to save storage space. Similarly, if standardization data requires stronger security measures, enforcing encryption may be needed. However, IDIADA administrators cannot meet these changing requirements because of the inflexibility of traditional block storage technologies. Thus, the lack of data management flexibility in the storage cluster is becoming an obstacle in IDIADA's daily operation. Problem 3. Provisioning of virtualized analytics applications. Arctur is a Slovenian data center that provides cloud services and hosting to companies and organizations. One of their most recent activities is to provision analytics applications for their customers, and even for their own internal use. Deploying and configuring analytics applications is an arduous task. This is especially true for new applications with tailored customer requirements. The problem that Arctur faces is considerable. The work of data center administrators increases with the number of applications that need to be deployed, and their increasingly complex customization. To solve these problems, we present IOStack. IOStack is the first open and extensible software-defined storage system for big data analytics. IOStack makes the management of the entire big data analytics lifecycle more straightforward. It ranges from advanced data services to the deployment of analytics applications. Overall, IOStack presents all its capabilities in a simplified and policy-driven manner for administrators. To achieve the project's objectives, the consortium has integrated innovative features in IOStack so that it goes one step further than state-of-the-art systems. IOStack includes a novel cutting-edge SDS architecture for object and block storage. In fact, SDS is still in its infancy, and there are very few systems that offer true SDS control of storage clusters. This may allow Europe to be a leader in this sector. Moreover, unlike most existing SDS tools, IOStack does not cover only the automation and orchestration of storage resources. IOStack design is conceptually separated into control and data planes. On the control plane, administrators enforce policies to change the behavior of the system. On the data plane, storage filters intercept storage flows to execute the transformations defined by policies. The key goal of IOStack is that filters are transparently enforced on storage flows, and new filters can be plugged into the system to extend its capabilities. This makes IOStack open, extensible, and policy-driven. The IOStack platform consists of the following building blocks. On the storage level, we find two building blocks: Crystal, SDS for object storage, and Connector, SDS for block storage. Both blocks are built on top of OpenStack Swift and Cinder, respectively. On the compute level, we find Zoe, a policy-driven analytics as a service framework. Zoe enables data analytics applications to be virtualized on top of Docker containers. Finally, these building blocks are fully integrated into a unified, user-friendly dashboard that extends OpenStack Horizon. Crystal, SDS for object storage. Crystal is the first open and extensible SDS architecture for object storage. In Crystal, an administrator defines policies via a simple meta-language on the control plane. These policies may trigger the enforcement of storage filters on the data plane. For example, a compression filter can be installed in Crystal. Then, a policy can be defined to enforce data compression on data objects of tenant T2. As can be seen in our example, once this policy has been defined, Crystal automatically detects T2's data objects and transparently enforces data compression, thus saving storage space. This is just one simple example of Crystal's capabilities. Crystal also makes it possible to execute a wide variety of services on data objects. This includes a solution for the grid pocket use case. In Crystal, we developed a storage filter that can discard unnecessary data in the storage cluster via active storage techniques. Once this storage filter has been installed, the administrator can enforce the filter at tenant grid pocket via simple policy. With this in place, analytics applications of Grid Pocket can tell the new filter what data will be necessary for a given query and discard the unnecessary data on the storage side. As a result, Grid Pocket queries are much faster, and this increases the competitiveness of the company. Connector, SDS for block storage. Connector is the first SDS system that makes it possible to enforce arbitrary filters on block volumes. With Connector, an administrator can easily mount block volumes enriched with several storage filters via simple policies. Storage filters can be enforced on both the client and the server sides. For instance, imagine that an administrator wants to apply compression and encryption to data flows for a particular volume. To do this, the administrator needs only to install the filters that will execute the actual compression and encryption functionalities in the connector's filter framework. Then, the administrator defines that these filters will be enforced on the desired block volume. From this point onwards, Connector will transparently apply compression and encryption filters on data flows related to the virtual machines that mounted the target block volume. Connector fits the IDIADA use case for block storage perfectly. Thanks to Connector, IDIADA administrators can change the behavior of the block storage system when there are new requirements. In our particular example, Connector makes it possible to install compression and encryption filters in the system and to define policies that enforce them on compute instances that manage car crash data and Volkswagen standardization data, respectively. This makes IDIADA sufficiently flexible and agile to respond to the unexpected storage requirements of their daily operation. Zoe, policy-driven analytics as a service. Zoe is a framework for launching complex data analytics frameworks in a simplified and policy-driven manner. It also makes it possible to dynamically manage data analytics applications with advanced scheduling and elasticity strategies. To show how it works, let's imagine an administrator that aims to spawn several clusters of virtualized analytics applications, like Spark or Hadoop. The administrator only needs to provide Zoe with application descriptors that define how these applications should be deployed. Zoe automatically builds, deploys, and monitors these data analytics applications in seconds, without further human intervention. Zoe makes it quite straightforward to deploy analytics applications in compute clusters and considerably increases management options. In our project, Zoe already satisfies the needs of real use cases. In particular, the Arctur data center can now provision a variety of analytics applications simply and quickly. Even in the event of a new application, Zoe makes it much easier to deploy a cluster with a simple application policy in seconds. For Arctur administrators, this saves time and reduces costs. IOStack is an integrated and user-friendly front end that extends OpenStack Horizon. On this dashboard, an administrator can manage data objects with Crystal, mount filtered volumes with Connector, or spawn clusters of analytics applications with Zoe. It also provides monitoring tools so that the administrator can dynamically manage the cluster. Our objective is to make the management of big data analytics simple, intuitive, and policy-driven. Conclusions. IOStack makes the management of big data analytics in the cloud straightforward and policy-driven. With IOStack, companies can enforce advanced services on their data, be flexible in their management of their storage, and provide entire clusters of analytics applications. IOStack is open and enables a white label business model for European companies and data centers. We also provide a ready-to-use integrated prototype, which has several deployments that are currently running. Do you want to know more? Check out the IOStack webpage at iostack.eu and follow our Twitter account. And feel free to join our open source community at GitHub.